We saw how you can use path names to refer to files that are not in your current working directory. It turns out there's two kinds of path names. There's absolute path names and relative path names. When in doubt, always use the absolute path name. The disadvantage is this can be very long. Okay, so let's take a look at absolute path names. An absolute path name, that is a full path name, traces a path from the root to the file. You're guaranteed that any file on your file system will have a unique absolute path name. Problem is, it might be very long. So to get around this, we'll see in the next slide or the next couple of slides that you can use relative path names, but relative path names can be troublesome because you might have two files that have the same relative path name depending on where you are. So that's the problem with relative path names. So when in doubt, always use the absolute path name. An absolute path name, so the only difference between absolute and relative path names is that absolute path names always begin with the root directory. So if you see a path name that starts with the root or slash, you know for sure that's an absolute path name. For sure, if that file exists, that is a unique path to that file. Relative path names do not start with a slash. They would start, for example, with a USR, /David /myfirst. That would work if you are in the root directory. Okay, so you'll get used to this. Okay, so if your working directory is user /user, the absolute path name of the file called myfirst under the directory David is /user /David /myfirst. So the absolute path name specifies exactly where to find a file. Thus it can be used to specify the file location in the working directory or any other directory. So if you are in some directory and you want to locate a file, you can always use the absolute path name to find that file. Absolute path names always start from the root directory, and so they always have a slash at the beginning of the path name. Relative path names give you the option to use a shorter path. So if, for example, you have hundreds of directories, it gets very cumbersome to use absolute path names, and at that point you probably might want to just use relative path names. So relative path names are shorter, traces a path from, and here's the important thing, from the working directory, your current position in the file system, to a file. Okay, so absolute starts from the root. That's why it's called absolute. It's an absolute position. Relative means relative to where you are in the file system, that is, it traces a path from the working directory to a file. Like the absolute path name, the relative path name can describe a path through many directories. You can have many directories. There's many levels of directories that you can have in the path. So for example, if your working directory is USR, the relative path name to the file called report under David is David /report, assuming David is inside the USR directory. Notice there is no slash at the beginning of a relative path name. It always starts, it's implied that you start with the current directory. Okay, so there's a few more concepts that you need. Let's just go over some of these. Every ordinary file and directory file has a file name. You can have multiple directories with the same file name, but they have to be in different locations. And Unix gives you a lot of freedom in naming your files and directories. You can even have spaces now in your files and directories. That was not something that was possible a few years ago. All Unix systems allow a file name to be at least 14 characters. So the most restrictive Unix system will have 14 characters for file names. And I think, I haven't tested this, I believe that file names under Linux have to be can be a max of 255 or 256 characters. I believe that's the limit. So that does not include the path. That's just a single file can have a name that's 256 characters long. Okay. You can name a file using a combination of characters and or numbers. You can put in a whole lot of characters, although it's very useful to avoid these characters. I don't think the Linux system will stop you from putting these characters into a file name. Some of them it might be hard to create files with these things, and I think these are things you want to avoid just so that your life is simpler. You just don't need the trouble that comes with naming files with these characters in them. Okay, so remember, keep this in mind. These are all characters that you should not have in file names. You want to choose characters from this list: uppercase characters, lowercase characters, uppercase and lowercase letters, digits 0 through 9, underscores are okay, dots are fine too. On Linux systems, on almost all Unix systems, you can have file name extensions, and it helps you, the user. It doesn't actually do much for things like for operating systems. You can, for example, have a movie file with no file name extension. You can choose to do that if you want to on Linux. It used to be on Windows and on Mac OS X that if you set up a movie file without a file name extension or a text file without a file name extension, you could sometimes get into trouble. And I think those systems are moving towards how Unix does things too. That is, the file name extensions are not always that important. Sometimes it does help. And so in Unix, in most cases, file name extensions are optional. So we will use the .c file name extension for C programs, and some of you might write C++ programs, in which case you will use .cpp. Okay. So you can use, actually, let me just go back, you can use more than one period. That is, you can have memo.04.10. I find this useful. For naming files, I will use the date, the current date, and I'll use, for example, 2013.01 for January, and so on. So those are definitely options that are open to you. Okay. So we will go through a bunch of these examples, or the book goes through a bunch of these examples where you have a fictional file system, an example file system, and we'll take a look at how you go around in this file system. Okay, so let's say you log in, and as soon as you log in, you type in pwd, and what that will give you is your home directory. So pwd, right when you log in, will say something like, on the live CD, it'll say something like /home/uwrf. Okay, and then you get the shell prompt. So this is a little bit different from what the live DVD has. So let's pretend you're David. If you were to log in, you will get this as your home directory path, and also your current working directory when you first log in. Since it starts with a slash, this is an absolute path name. Okay, so if you are over here, you're positioned over here, that's your current working directory. If you say source/first.c, you're referring to this file, and that would be a relative path, source/first.c. So you could, if you are positioned over here, if you want to edit this first.c file, you can say from here, you say vi source/first.c. Or if you want to edit this file, first.cpp, and you are positioned here, you can say vi source/first.cpp. To change your current working directory, you can, for example, say cd to source. And then once you're over here, if you want to edit this file, you just say vi first.c. If you have permissions to, for example, go to the root directory and then to dev, you can say cd space, there's a space over here, /dev return, and that'll change your current working directory to /dev. I think you probably will have permissions. Let's just try that. So say cd space /dev. Sure enough, we do have permissions to go there. Let's see if we can list files. Sure, looks like it's okay. There's a whole bunch of files there. And let's cd back to our home directory and clear. Okay. In this next section, we will see how to create directories. So far, we haven't actually done that. We've just used the file system. We've been navigating around the file system and using what's already there. So the very first time you log on to Unix system, you begin work from your home directory, which is also your current working directory. If you have, let's say, hundreds of images or something, it's often advantageous to put them into different directories based on, for example, the date, something like that. Okay, so that's why typically if you have many files, it's always good to create directories of files just to organize your data. So some of the advantages of using directories: grouping related files in one directory makes it easier to remember and access them. Displaying a shorter list of your files on the screen enables you to find a file more quickly. For example, if you organize by date, you can cd to the right directory and so on. Or alphabetically, let's say you have text files, you can organize them alphabetically. For example, A through E and then F through G, stuff like that. You can use identical file names for files that are stored in different directories. What does that mean? You can have two subdirectories, and they can both have a file called report or readme, something like that. Directories make it feasible to share a large capacity disk with other users with a well-defined space for each user. And usually there's security constraints. That's what permissions are all about. We ran into that. Each user has permissions typically to use parts of the system, but then they cannot really look at files that belong to a different user. Typically that's not allowed. At the same time, it's also important to share files. So two users might want to share files, and that's also possible. So we'll see how that's done.